Without wasting much time, in today's video, I'm going to take you all to the linear motion in physics, starting from the year 2024 back to the year 1995. Actually, there are 29 questions. Now, this is from the year 2024, 14 part of the question. This is really essential so that you can be able to know how questions are asked in different topics. So here we have the displacement of a particle is given as s equals to s raised to power 3 plus 5s minus 4. Find the equation for its velocity. So what is the equation for the velocity of a displacement represented by this equation? Now, what they are trying to do here, or what you are going to do here, is differentiation. You're going to differentiate this expression here with respect to the velocity. So according to differentiation, so we are differentiating the distance, which is the displacement, to be the v over the time. And what are we differentiating? We are differentiating 2x cubed plus 5x minus 4. Now, if you have not come across differentiation, I made a video on that. Now, this is differentiation or of addition. What we need to do here is, anywhere we see power, we are going to bring that power down and we take away 1 from it. All right, so from this, I'm going to have that 2x3, differentiating it, 3 is going to come down. I'm going to have 2 multiplied by the 3, I'll have s. Now, this 3 that comes down is up to 3 places. There are three places here. So one of the 3 comes down, and now I'm going to minus that 3 that I brought down. So I'm going to add it to this s here has invisible power of 1. So that invisible power of 1, I'm also going to bring it down to multiply it by 5. Now the s, that invisible power, I'm going to take away 1 from it because I brought out the 1 down. And now, as a constant, this is equals to 0. Any constant in differentiation is equal to 0. Now, furthermore, I'm going to have 2 times 3 is 6, x 3 power minus 1 going to give me 2, plus 5 multiplied by 1 is 5, multiplied by s is 5s. Now, 1 minus 1 here is going to give me 0, and I have minus 0 is going to give me the same thing. This is furthermore equals to 6x squared plus, now s raised to power 0, any number raised to power 0 is 1. Now 5 multiplied by that 1 is going to give us 5. Now you stop your differentiation from here, which is very much equals to the f prime. F prime means we just differentiated once. So if we have to differentiate again, we have to bring these 2 down again and minus. But here we just have to differentiate once to find the velocity of this expression. So this is our final answer, 6x squared plus 5. Now this is it in option B. The second question we have here was back to the year 2021. So from 2024 to 2021 was where the question was asked again on 13th part of the question. It says, which of the following velocity time graphs most suitably represents a solid iceberg pushed forward on a smooth horizontal surface? Now I'm going to start explaining from option B. This option B here represents an object released from a great height, thereby attaining a terminal velocity whereby the acceleration is going to be what? Increasing. So this is the body falling back down due to what? Decrease in the velocity. Now here, option C represents an object thrown vertically upward. When the velocity becomes 0 due to the acceleration of gravity, it started falling back down in a slant way. Okay, now the option D, which is the last option here, represents an object on a lift, like between 2 floors, whereby the acceleration is accelerating and as well as what? Decelerating. If I should make this graph more longer, you're going to see it's going to accelerate again and decelerate. So this is an object on a lift between 2 floors. Now, the correct answer is option D. When something is moving horizontally, the graph is going to be in a straight form. The next question, back to the year 2018, on the 17th question, it says a body moves at 20 meters per second, decelerates uniformly at 5 meters per second square till its speed becomes 10 meters per second. The distance covered within its period is, so we're looking for distance which is represented as s. Now, analysis and solution, we are given data such as 20 meters per second, per seconds means velocity. So that is the initial velocity which the body moves, and it is 20 meter per second. Now, it's decelerate uniformly at 5 meter per second square. Deceleration also means acceleration, whereby deceleration is decrease in acceleration, while acceleration is when the speed is positive. It is what? Accelerating. Now, it decelerate at 5 meter per second square. So we use square to denote what? Acceleration or deceleration. So now acceleration is going to be negative because it is what? Reducing, negative 5 meter per second square. And again, each speed becomes 10 meter per second. We denote it as the final velocity, which is 10 meter per second. Now we are looking for the what? The distance, which is s. Again, you should have the four equation of motion, I mean to say, at your tip, so that the first one, which is v is equals to u plus at equation 1. The second equation is equals to s equals the average velocity u plus v over 2 multiplied by time. This is equation number 2. The third equation says that s is equals to ut plus half at square. And then the fourth equation says s is equals to, sorry, it says v square is equals to u square plus 2as. So these are the four equations of motion. Now, how can you select this equation of motion? Look at the data given. You are given velocity, initial, acceleration, velocity, and final distance. Once you are not given time in a motion, a time of how the motion is going, you have to forget the first equation, which have time, the second equation, which have time, the third equation, which have what? Time, and go over to the last one equation, which you cannot see time in it. Or if you are not given the time and asked to find the time, then you have to select any one of these depending on the other variable given. For example, if you are not given the initial velocity, if you're not given the final velocity, I mean to say, you consider using this when you have the time. And if you're given the initial velocity and the final velocity, you now go to use this one. But if you're not given the final velocity, consider using equation 3, although we are still going to analyze it as we move on. So the equation suitable now is this final equation, so that v square equals u square plus 2as. Substituting my value, v is equals to 10 raised to the power 2, and u, which is initial, is 20 square plus 2. My a is negative what? 2 multiplied by negative 5 multiplied by the unknown value, which I'm looking for, s. Now this 10 raised to the power 2 come over, and 20 raised to the power 2 comes over here. I'm going to have 10 raised to the power 2 minus 20 raised to the power 2 equals 2 multiplied by minus 5 is going to give me minus 10s. Okay, I have minus 10s. So here, if I should say 10 raised to the power 2 is going to give me 100, whereby 20 raised to the power 2 is going to give me 400. To do this, you're going to say 1 raised to the power 2 is 1 times 1, and then 0 up to 2 places. Now 2 raised to the power 2 is 4, and then 0 up to 2 places equals minus 10s. Now I'm looking for s, which is the distance, and not minus 10. Remind you, this is not 5, this is s. This is not 5, this is s. So I'm going to divide both sides by minus 10 and divide by side by minus 10. This cancel this. I'm going to have s to be equals 10. 100 minus 40 is going to give me minus 300, because 100 is too small to minus 40 over 10. This will cancel this, so that s, which is the distance, equals 300 divided by 10. This cancel this. Then 30 over 1 is 30, and measured in meters. So where is the option? Option number A. Next question is on 2016, and there are two types of questions asked. It says the first one, which is the seventh one, and our fourth question in this video, says the inertia of a body is defined as the A, reluctant to keep moving if already in motion, B, readiness to start moving if in the state of rest, C, reluctant to start moving if in a state of rest, D, ability to overcome the Earth's gravitational pull. Now, the inertia of a body is trying to tell us the weakness of a body to start moving when it is in the state of rest. Also, the weakness in a body to stop moving if already in motion. Now, this we have that it is what? Reluctant. It is the reluctance of the body to start moving, when it is at what? Rest, and stop moving when in what? Motion. When it is in rest, the reluctance is called initial, to start moving, and to stop moving when in motion is called what? Initial. Now, here we have reluctant to keep moving if already in motion, whereby we have stop moving if already in motion. So this is cancelled. Here we have readiness to start moving if in the state of rest. Readiness means something that is waiting, or the strength you have to just start moving, whereby we have to start moving when in the state of rest. So it's reluctant to start moving means the weakness you have to start moving. So here it doesn't want to move if you're talking about inertia. The sixth option C says reluctant to start moving if in the state of rest. So reluctant to start moving if in the state of rest. So C is the option that is correct. Let's go to D. Ability to overcome the Earth's gravitational pull. I want you to tell me on the comment section, what is ability of a body to overcome the Earth's gravitational pull when you want to cross the Earth? So I made a video on gravity. I mentioned that. Let me know it on the comment section. Now we are going over to the 39. So this is our fifth question on this video, which is the 39 part of the question that was asked in year 2016. And this question is the same with the question asked on 2015 on the 50 part of the question. So the 50 on 2015 is the same thing with the 39 on 2016. So they repeat the question. Here we have it as a train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is that. A complete halt means when the body comes to at rest. So we say that initial velocity u is given to be 20 meters per second, and then it is decelerating under 2 meters per second. Acceleration is going to be negative because it is decelerating, it is reducing, negative 2 meters per second square. That is the difference. And then the what again? We should calculate the time required, t, which is the time is unknown, and here it comes to at rest, which is to a complete halt, which is going to be acceleration of 0 at its resting point. Now we're going to use that v is equals to u plus a t square. So this is a formula that is suitable for this expression because we have the u, we also have the v, we have the a, and we have the time. Whereby if we go with the second formula, which is f equals to u plus v all over 2 times t, you find out that we have a distance which is not required and was not asked. Okay, now if we use what again, x is equals to ut plus half a t squared. If we use this, find out that we also have s, which is not involved, and again u is there, but there is no final velocity. This is how you can choose your formula. Let's say again we have that v square equals u square plus 2as. You can see that if you have chosen this equation, s, which is distance, was not given in the question and we are not looking for it. So this is a suitable formula to use, whereby my v, I'm going to use this and substitute the value. My v is 0 here, equals to u, which is 20, plus at, a is negative 2 multiplied by time. I'm going to have 20 coming over here becomes negative 20 equals to negative 2 multiplied by time is negative 2t. Now I'm looking for t, not negative 2t. Divide by 2, divide by 2 in the both sides. So I have only t left equals this cancel this, and 20 divided by 2 is going to give us 10, and it is a positive 10 in seconds. So this is our option number B. Question in 2015. Mind you, we have solved the 50th part of the question 2015. So there are 3 questions from linear motion. This one is the 4th one, and which is our 5th question in this video. We have that what is the force? The force, what force has to be exerted on a mass 60 kilograms to give it an acceleration of 10 meters per second vertically upward. All right. And the gravitational due to acceleration due to gravity is 10 meters per second. Look at what you're going to do. First of all, let's look at the given data. The given data was the mass of the body m equals 60 kilogram, and again the acceleration is 10 meter per second. Alright, a is 10 meter per second, and acceleration also due to gravity is 10 meter per second square, which is g. And then we are looking for what? We are looking for the force to make this body to move up to 10 meter per second. So this force is the question. Now let's analyze this. This is the body. Let this be the body. This body is what? 60 kilogram. This body has a mass of what? 60 kilogram. Now we want a force that is going to make this body to move up. And that force, we don't know it, is unknown. All right. If this body is moving up, another force is going to pull it down, which we call what? The weight of the body. So there are two forces acting on the body. This one is pulling it down, known as a W. Now, which the weight of the body is equals to the mass times acceleration due to gravity. Now, for us to be able to tackle out this force here, we are going to use the Newton law of motion, which state that force, which is going to be the net force, is equals to mass times acceleration. What I mean by net force is, for instance, if I have gotten this force here to be 100 newtons, and the weight of this body to be let me say 20 kilogram, all right, sorry, 20 newton also. Now if I should subtract the force that is pulling it up and subtract the force that is pulling it down, I'm going to have what I have called net force. The net force is what is going to let this body to pull up. So I'm going to need a force that is going to conquer or win this force that is pulling it down to be able to push it down. Now that force that it's used to conquer this body has gone out, and the force that it's now used to start moving up is what we call net force. And this net force, like I said, could be gotten, the net force could be gotten from using the force you are using to move up and minusing the force that is what pulling it down. Now the net force, which is F minus W, I can substitute it here to have that F minus W equals to MA, which is mass and acceleration. Also, we have to know that W is mg, F is now minusing mg, mg equals ma. Now minus mg crossover, we're going to have F equals to what? Ma plus mg. Here I'm going to factorize m because they are common term. M is going to come out, and I'm going to have m multiplied by a is still going to give me ma plus m multiplied by g is going to give me mg. So this I factorize it out. Now I have to substitute my value. F here is equals to m, which is the mass, is 60, and again the acceleration is 10, and acceleration due to gravity was given to be 10. Hence we have to say that 60 now multiplied by 10 plus 10 is 20, and this is the force. And the force now finally is going to be equal 60 times 20 is going to give us 1200, and the unit is on Newton. Look at the option, we have it to be option number B. Now let's go to the 26th part of the question. Before that, note that this is the force that is going to be pulling this body upward, and another force is going to be pulling it downward. Now let's try to calculate the force pulling it downward, but that's not the question. So that mg, which is the force pulling it downward, is equals to the mass, which is 60 times 10. All right, 60 times 10 is going to give us 600. So 600 is pulling this body down. Now let's look for what is this net force, which is the force that is now going to make it to go up. So the force that is pulling it upward, we got it to be 1200. And now the force that is pulling it downward, we are going to minus it to have what? 600 equals. Now if you use 600 and minus from this, you're going to get a value which is equals what? 600 Newton. So now this 600 Newton is what we call net force. When you use the force you're using to pull a body and minus from the force that's pulling it down, if they minus each other, the force that went out has conquered the force that is what? Pulling this body down. Hence, the body is going to move up with a force of 600 Newton. All right, so this is the force that is what you're using to pull it, but the net force, which is now making this body to go up after conquering the force that's pulling it down, is what we know as net force, and it is 600 Newton. And here we say calculate the total distance covered by a train, total distance before coming to rest if its initial speed is 30 meters per second with a constant velocity of 0.1 meter per second. Constant retardation, I mean to say. So to do this, let's write the three equations of motion. V equals to u plus at and v square equals to u square plus 2as, whereby s is equals to ut plus half at square. Equation 1, equation 2, and equation 3. So now we want to choose the parameters. From here, we are given data before coming to a rest. So before coming to a rest, the final velocity is 0 when the thing will come to a rest. If its initial speed u is equals to 30 meter per second with a constant retardation. Retardation means acceleration that is what? Decreasing. You can call it retardation or you can call it deceleration. So it is equals to acceleration A is equals to minus 0.1. It is going to be in a negative sign. So from this place, we have what? We are looking for what again? Distance, which is what? S. Now, if you look at this expression, we have V U, A, and looking for what? S. So we have V U, A, and S. If you look at here, we have V, U, A, we have T. I get in. We don't have what? S. So because of this T, we are not going to use that expression. If you come to the last one, we have S, which is what you are looking for, but we have T, and we don't have what? V over here. So because we don't have T in any of what we are looking for, we're not going to make use of this expression that have T. And again, if you look at this expression, it doesn't have the final velocity. But this expression here have what? V, and it have U, and it has A, and also have what? S, which is what? The distance. So I'm going to make use of it. Hence, V square equals U square plus 2as. The V, which is the initial velocity, is 0 over square equals U, which is 30 to square plus the 2 multiplied by the minus 0.1 and then multiplied by s, which is what I am looking for. Now, if you say 0 to square is going to give you 0 equals 30 to 30 raised to power 2. What we're going to do is 3 times 3 square is going to give you 9 and 0 to 2 places plus 2 multiplied by negative 0 point. This is in bracket, I mean to say. This 2 multiplied by this is going to give us what? 2 multiplied by 0 is 0. 2 multiplied by 1 is 2. So I'm going to have negative what? Negative 0.2 multiplied by s, negative 0.2 s. Now, because I'm looking for s, this 900 is going to cross over here. I'm going to have negative 900 equals negative 0.2 s. Now, because I'm looking for what? S, because I'm looking for the value s, what is going to happen here is that I'm going to divide both sides by negative 0.2. So divide both sides by negative 0.2 divided by negative 0.2. This is going to cancel this. I'm left with what? S, which is going to be equals. S now equals this negative will cancel this negative. Now 900 divided by 0.2, 900 divided by 0.2 is going to give us 4,500, which is in option B. All right, so 4,500. Now we move over to the next question. Hope you understand this. Let me know in the comment section. The next question says, a car starts from rest and moves with a uniform acceleration of 3 meters per second for 20 seconds. said calculate the distance covered at the end of the motion. You may be confused when you are reading the question, but when you put down the parameters, it's going to be more easier for you. So a car starts from rest, meaning that the initial velocity it was resting is 0. So we are giving data, analyzing it, initial velocity is 0. So here, and moves with a uniform acceleration of 3 meters per second. So it is not deceleration or retardation, it is positive one acceleration. A, which is acceleration, is equals to 3 meters per second square for 20 seconds. So the time is 20 seconds. And again, calculate the distance covered at the end of the motion. We still want to calculate another distance, which is s is equals to what? Unknown. Now, if you look at this formula here and look at these parameters given, we are given the initial velocity. As you can see, there is no final velocity. We are just giving the initial velocity and then the acceleration, the time, and the distance. So a car starts from rest and move with a uniform acceleration of 10 meters per second in 20 seconds. We are not told the velocity it was attained, so there's no what final velocity. Now, if you look at this expression, are we to use this first equation of motion? We have v, whereby we do not have v, and v is the what final velocity. So this one already has been terminated. Are we to use this second equation of motion? Here we have u and here we have u, but this one has v, okay? This one have what? V, but we don't have what? V, which is the final velocity. And if we come over to this point here, so we are looking for the equation that does not have the word final velocity. And this last equation of motion says that s is equals to ut plus half at squared. Now, there is nothing like what? V here. We have x, which is what you are looking for. We have u, which is initial 0. We have t, which is what? The time. And a, we have a. Now, once the acceleration, so once the body starts from rest, this formula which we are going to use that say that s is equals to ut plus 1 over 2 at squared. Once the initial velocity is 0, note that if we substitute 0 to initial velocity here, if the 0 to multiply by the time, which is 20, you are going to have what is left here to be what? 0. So this formula will now become s equals half at squared. You must bear this in mind. Once you have it to start an initial point, you are solving is now going to become easier for you. Now, s, which is what you are looking for, is now going to be equals to, substituting this value, I'm going to have half of a is what? A is 3 multiplied by t is 20, and 20 raised to the power what? Square. I'm still going to have half, what is 3 multiplied by 20 square is going to give us what? 2 raised to the power 2 is 4. Now 0 will now be to what? 2 places. All right. Now I go again by saying that 3 times what? 400. Let's first count in 4. I count like this: 4, 8, 12. So here we're not going to put it in 1200 instead of what? 12, because we have what? 2 0. So I'm going to have what? Equals to 1200 over 2. I'm telling you how you can use your head without what? Calculator offhand. So 1200 divided by 2 is going to give us a value which is what? In the next, we have two questions. This is 2003, the sixth part of the question. Now, this question, I have done this question before. It's a repeated question. It says, a train with an initial velocity of 20 meters is subjected to a uniform deceleration of 2 meters per second. We have done it in the time. What is the time taken for the train to come to a complete halt? So you have heard me say that. So we have done this expression. And we got the answer to be what? To be 10 meters per second. Let me just use this and show you the velocity time graph. So a body on 20 meters per second, this is the velocity vertical, this is the time, is decelerating with 2 meters per second, is decelerating and come to a rest. So here I have it to be what? 2 meters per second square, the deceleration speed. So here we are looking for the what? The what time is going to take the train to come to a complete halt, whereby the final velocity is going to be 0. So after calculating, we got the answer to be 10. Now the next question says that on 2012, the first part of the question we have in this diagram says from the velocity time graph shown above, which is it, which of the following cannot be determined. So here, is it this deceleration that cannot be determined, or B, is it initial velocity that cannot be determined, C, is it total distance that cannot be determined? Now, D, is it initial acceleration that cannot be determined? Now, for this deceleration, the deceleration of this can be determined over here, whereby you use V equals U plus AT. The A can be determined whereby you substitute this other value. So it is not A, which is option A. Now go to B, initial velocity. The initial velocity of this object is 60 degree. It is moving with 60 degree and now start to what? Decrease. So if it starts to decrease, the final velocity is going to be 0, but the initial velocity can be what? Determined. So this is not the option we are looking for. Option C, total distance. Now, the total distance is distance traveled by this object, and note that distance could be expressed as velocity times time. So once you use the velocity of the object, the average velocity, and multiply by the what? The time, you're going to get the what? The total distance, which could be gotten. So not the answer. Now, initial acceleration. There is nothing like initial acceleration, or there is, but initial acceleration is not being shown on this diagram. Now, let's move to another question under this 2012 paper. 600 meter. Now, 600 meter, if you look at the options, you have them to be in kilometer. To change it to kilometer is divided by 1,000. Divided by 1,000 is going to give you 0.6 kilometer. If you look at the option, you have 6 kilometer, 12 kilometer, 8 kilometer, 24 kilometer, and this value you got is not in the option. You know that what? The answer is not correct. Not the answer, I mean to say, the options is not correct. So there's no option here that is what? Correct to what the question is asking. Hence, you cannot say that there is no correct answer, you leave the option like that. You're going to pray to God and choose the one that is closer to your answer. But this is the correct one, kilometer. No option here is correct. Let's go to the next part of the year question. 2011, seventh part of the question. An object of mass 2 kilogram moves with a velocity of 10 meters per second round a circle of radius 4 meter. Calculate the centripetal force on the object. Now, force is given by mass times acceleration, while this force is the force in a circle. Now, this known as centripetal force, the acceleration is A, which is the acceleration, is going to be as a centripetal acceleration, whereby a centripetal acceleration is given by the velocity square over the radius. Substituting that over here, we're going to have that the centripetal force is going to be equals to mass times velocity over radius, whereby the mass of the body given here is 2 kilogram. 2 now multiplied by the velocity, which was given as 10 meter per second times 10 to square all over the radius, which was given as 4 meter. The radius was given as 4 meters. So here we are going to have 2 now multiplied by 10 raised to the power 2 is 10 times 10, giving us 100 over 4. Now, before we do this, we can use 2 to cancel here 1, to cancel here 2. This is equals 100 over 2 equals what? 50, and measured in what? Newton. We have centimeter force to be what? 50 Newton. The next question, I have two questions, and this one and this one in the year 2003 and 5. This is the third one, this is the fifth one over here. Now we have that the diagram above shows a velocity time graph. The statement that is true about this motion is that the car A has a constant speed between E and F. Constant speed between E and F. We analyze that has no acceleration between point F and G. decelerate between point F and H. That is the end. So what do we have to note here? You have to know that from this point to here is where this motion is accelerating. Is what? Accelerating. It is accelerating. And from this point to this point, it is where the car is decelerating or having a retardation. Also, from this point to this point is where this motion is in a uniform velocity. At this point, there is no acceleration. Acceleration, for example, let me say acceleration is that thing that you used to hear from a vehicle. It moves boom. If you move boom at a point, you will now start doing boom. Boom is the acceleration. Boom, boom. So it's no longer adding the acceleration to increase the speed. It is now under a constant velocity or uniform velocity. That is now at this point you now start decreasing a deceleration. Now from here we have has a constant speed between E and F. Where is the E? E and F is not a constant speed. Where it has a constant speed is in F and G. So option A is not correct. What it has here is a what? Uniform acceleration. Here is a uniform deceleration. So this says acceleration between point F and G. It has acceleration between F and G. Where is the F? This is F and G. At this line here, which is F and G, there is no acceleration. Rather, we have what? Uniform what? As velocity. In option C, has no acceleration between point F and G. Has no acceleration between points. This is the point F and G. It is correct because there is no what acceleration in this point here. What we have here is what uniform velocity. After it have already accelerated to that velocity, now continue constant. Now let's just go to D. It says decelerate between point F and H. Decelerate between point what? F and H. You cannot from this point and go to this point. It's not deceleration, but it decelerates from what? G and then H. So our correct answer here is the option what? C. Now moving over to this part of the question, which I said that there were two questions. Here it says a car moves with an initial velocity of 25 meter. I want to solve it here. We have what? Initial velocity, which is u equals what? 25 meter per second. And then and reach a velocity of 45 meter per second. That is the final velocity. It reached a velocity of 45 meter per second in 10 seconds, given time that it happens in 10 seconds. We have that what is the acceleration of the car? We are looking for a acceleration of the car. This question is very cheap and very simple. Hence, we have that V is equals to U plus AT. We are looking for what? Acceleration. Now, V, which is what we have to be what? 45 is equals what? U, which is what? 25 plus what? There is no space here. So I'm going to make A immediately a sort of formula. If this crossing here, I'm going to have that A alone equals V will be here. If U cross, I'm going to have minus what? U. And then since T is the coefficient of A, which is what I'm looking for, I'm going to divide it by what? T. Hence, if I have this expression to be in this form, solving it, I'm going to have that A now is equals, what is V? V is what? Final velocity, which is 45, minus initial velocity, which is 25, over time, which is 10, equals 45 minus 25. Remove 2 here, 2, remove 5 here, it is remaining 0, all over 10. Now, what could divide this? 10 could divide there to give us 1, equals 1, 10 divided give us 1, 10 divided there will give us 2. 2 over 1 equals 2. So the acceleration is equals to what? 2 meter per second squared. And that is the option given in option C, meter squared. Now, the next question. All of you, as you can see, the day is getting more better. So I'm going to stop here in this video. We still have 13 more questions left. So if you minus 13 questions from 29, you're going to have what is left to be 16. So now we have gotten to 16 questions from linear motion. I'm going to try to make the other part of the 13 question. It has a different approach and different from what we have been doing before. Please, if you like this video, don't forget to like on it, Subscribe if you are new to my channel. My name is Mentor Paul, all on the academy. If you're watching from WhatsApp, you can click the link on this video and it will take you to my channel where you are going to subscribe. Also click notification bell so that when I post the other video, you're going to be notified, because I'm going to be treating all the all the topic we have in different subjects, such as in chemistry, in physics, mathematics, biology, economics, civic education, government, and literature. Different approach, and excluding English, and English I'm going to say. So I'm going to solving different topic on this subject. So don't miss out anyone by hitting the notification bell.